8.2 covers the law of cosines. The law of cosines says if A, B, and C are the measures of the angles of a triangle, and little a, little b, little c are the lengths of the sides opposite these angles, then a squared equals b squared plus c squared minus 2bc times the cosine of a. B squared equals a squared plus c squared minus 2ac times the cosine of b, and c squared equals a squared plus b squared minus 2ab cosine of c. In general, the law of cosine says that the square of the side of a triangle equals the sum of the squares of the other two sides minus twice their product times the cosine of their included angle. So remember that C is the angle that's included between sides A and B. B is the angle included between sides A and C, and A is the angle included between sides B and C. So it's not like you're going to have to memorize 3 formulas here. You can just remember in general what this means and be able to use the law of cosines. So let's go ahead and try a few of these problems. Solve the triangle, round to the nearest tenth. So I have here a side, an included angle, and another side. So sounds like this is going to be my angle that I'm taking the cosine of, and I could use this here as my A. We'll just go ahead and label this B and C, and this is angle A. So our formula says that A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of 61 degrees. So this way we can solve for A squared just by taking the square root. We don't have to worry about the plus minus. We're not going to use any negative angles here. So the square root of 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of 61 degrees. We'll go ahead and put that into our calculator. So I have the square root there. 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of 61 degrees. And entering that, I get an A of about 5.4. Okay, so A is about 5.4. And now I need to figure out what angle C and angle B are. So here's my A is a 5.4. I need to find angle C and angle B. Be quick to just go ahead and do the law of sines if we wanted to. So let's go ahead and do that. I have a, let's see, we'll do sine of big C over 6 is equal to the sine of 61 degrees over 5.4. So sine of C is approximately, I'm going to multiply both sides by 6, so I get 6 times the sine of 61 degrees divided by, go up and grab that number on your calculator so you're not using rounded numbers, a 0.979 and take the inverse sine of that, and it tells me that C is approximately 78.3 degrees. So 78.3 degrees, I can take 180, subtract the 61, subtract the 78.3 that I just found, and that's going to be my B, is 40.7 degrees. Alrighty then. Now here's an interesting problem. Just go ahead and lay this out. Remember, it doesn't have to be to scale. We're just getting things oriented in the right position so we can picture this in order to do our calculations. We have 3 sides and no angles. So it really doesn't matter which one you want to go ahead and solve for first. Let's say that we wanted to solve for angle B. That means that we're going to do 421 squared equals the sum of the squares of the other 2 sides minus twice their product times the cosine of their included angle, which is B. Now, this is a little different because we've got to solve for B over here, and then it's the cosine of B. So let's get this simplified a little first. 421 squared, that's going to be 177,241. I'm going to go ahead and subtract 324 squared and subtract 298 squared. Okay, so that gives me a negative 16,539 equals, and this would be 2 times 324 times 298, and that's equal to a negative 193,104 times the cosine of B. Now notice I didn't just add this amount on to get it away from the cosine of B, because it is attached to cosine of B by multiplication. I know it sounds maybe obvious that I'm saying that, but this is where a lot of students make a mistake. They want to add this number to both sides of the equation to get cosine of B by itself, but you can't. You need to divide. So I'm going to take that negative 16,539 and divide it by this. Just remember it's negative, so your number should end up being actually positive 0.0856 and whatnot. We'll say is approximately the cosine of B. So then I can take my inverse cosine of that number that I just found, and I get a B of approximately 94.9 degrees. Okay, so B is about 94.9 degrees. I still need to get big A and big C. So, and you can fall back onto the law of sines if you like. So you can do that here. Let's do the sine of A over 324 is equal to the sine of 94.9 degrees over 421. I'm going to multiply both sides by 324. So sine of A is approximately 324 times the sine of, go ahead up, grab that number, 94 point, and so on, and divide it by 421, and we get 0.76677, and let's take the inverse sine of that, giving me A is approximately 50.1 degrees. All right, let's see here. That's not the only place that the sine of an angle is 50 degrees. We also have 129 degrees. But if we add the 94.9 degrees that we got over here, there's no way that that can happen. So we are only going to have the one triangle here. Don't forget to check those. All right, I've got 180 minus my 50.1 minus my 94.9, and I get a C of about 35.0 degrees. All right. Okay, here's another problem, very similar to the first. It's just that they didn't give you a picture. So just draw a triangle, any triangle, and remember, it doesn't need to be to scale. And we'll say this is little b. If this is big A, then this is your little a. And if this is big C, then this is your little c. We need to find big A, little b, and big C. All right, this is a problem where you have two sides and an included angle set up perfectly for the law of cosines. So we'll say that b squared is equal to 19.2 squared plus 15.1 squared minus 2 times 19.2 times 15.1. Oh, it's looking funny. Times the cosine of 168.2 degrees. And of course, b is just going to be the square root of that, so we can just put that all into the calculator at one go. Square root of 19.2 squared plus 15.1 squared minus 2 times 19.2 times 15.1 times the cosine of 168.2, and hit enter. We've already put that under the square root, so b is approximately 34.1. So b is about 34.1. All right, now you can go ahead and use the law of sines if you want on the rest of that. Let's say we want to find big A. We're going to say sine of big A over 15.1 is equal to the sine of 168.2 degrees divided by 34.1. So sine of A is equal to, I'm going to do my 15.1 times the sine of 168.2, close your argument, and divide that by the 34.1 above. Use that number in your calculator. So I'm getting about here is 0.09. All right, so the sine of A is 0.09, so we're going to take the inverse sine of that, and we get A of about 5.19, let's just say 5.2 degrees. Okay, this is not the ambiguous case, but you could go ahead and think about, just checking this. Where else would the sine of A be 0.09? It could also be there at 180 degrees minus that 5.2, so 174, but we already had a given angle of 168.2 degrees. There's no way you could have that other angle of 174.8, put you way over 180 degrees. So definitely only one triangle. This is not the ambiguous case. So finding C is easy. We'll take 180, subtract 168.2, and subtract the 5.2 from above. And C is about 6.6 degrees. All right. Now here's a word problem. There's really nothing very different about this than the other problems that were given to us, except that we have to draw it out. We have to read it and interpret what it means. So this is figuring out the distance across a ravine. So we have a ravine here. Let's see, one side of the ravine to the other side of the ravine. Points X and Y. So this is X, and here's Y. Points X and Y are on opposite sides of a ravine. From a third point Z, okay, we'll say Z is up here. Okay. From a third point Z, the angle between the line of sight to X and Y, so the difference between the line of sight right here is 37.7 degrees, and XZ is 153 meters long, and YZ is 103 meters long. Then we need to figure out what the distance is between X, Y. Okay. So again, it's a side angle side set up perfectly for a law of cosines. So we'll just call this distance right here a little z. Little z is equal to the sum of the squares of the other two sides minus twice their product times the cosine of their included angle. Okay, sorry, z squared is equal to that. So we're going to take the square root to get our z by itself. Let's just put that all in the calculator under square root. 153 squared plus 103 squared minus 2 times 153 times 103 times the cosine of 37.7 degrees, and I get about 95.3. 95.3, and that's in meters for us. Make sure and label it. All right, that's all up for the law of cosines. Now we have this formula. If you are given a triangle that has 3 sides given to you, then you can figure out the area of that triangle. The triangle has sides of length A, B, and C with semi-perimeter. Defines semi-perimeter as half of the perimeter. If you add the 3 sides together and take half of it, that's half your perimeter or your semi-perimeter. Then the area of the triangle is given by this formula. Again, they put this in script here so it doesn't look like angle A. So this is area is the square root of semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. So let's see how we would use that. We first have to figure out what our semi-perimeter is. It's 1/2 of 22 plus 45 plus 31. So S is, here we go, 22 plus 45 plus 31. There we go. And oops, I did a times, fix that, did a plus, and so that's 98, and then of course if we divide that by 2 we're going to get 49. So our semi-perimeter is 49. That means that our area is equal to the square root of 49 times 49 minus 22 times 49 minus 45 times 49 minus 31. All right, if you want, you could just throw that all into the calculator as is, or you can simplify underneath a little bit first. It's up to you. 49 times parentheses 49 minus 22 parentheses 49 minus 45, which is 4, close parentheses, another parentheses, 49 minus 31, close parentheses, and we get 308.6. So the area is about 308.6 square inches. Remember, area is a squared measurement. All right, that does it for your 8.2. You can get onto that homework. Have a great day.